All right, team, here we've got chapter 3. We're doing some probability. Of course, I have some vocabulary for you to get copied down. I'm going to pretty much skip over discussing what these are because when we do the examples, you will be able to refer to them. So pause the video and copy this stuff down. The counting principle is going to go with example number 1. The slot method is going to go with example 2. So make sure you've jotted those down because that's what I'll be referring to in class when we're doing these examples and stuff. But I'm going to go right into example number 1. There's 6 flavors of yogurt, 4 types of granola bars, 5 different juices to choose from. How many different types of breakfast can I have? What is the all the different combinations that I can make? So when you were in geometry class, I believe you probably did some brief problems like this. But these are independent events, and that's what I have written down right here. It doesn't matter what granola bar you choose. It has no impact on what flavor of yogurt you choose. That's called independent. They do not depend on each other. So we're going to use the counting principle, aka the slot method. And so what I'm going to do is make 3 slots. The first slot represents how many yogurt choices I have, times the second slot represents how many granola choices I have, and the third slot represents how many juice choices I have. And for the slot method, you always multiply these things. So different types of yogurt, there were 6 of those. There were 4 different granola bars and 5 different types of juice. All you do, you guys, is multiply those straight across and you get 120 different breakfasts. So super simple, and hopefully you remember doing a little bit of that from geometry. If not, nothing too crazy to have to worry about. But example number 2, different license plates, really common types of things, types of questions. How many different possible license plates? We've got 2 letters, the first of which is Q, followed by 3 digits. So we have a specific order that we have to go with. I am also going to make different slots here, and I'm actually going to use the slot method here because these are dependent events because we are not allowed to repeat digits. So the first digit or the second digit depends on what the first one is. That's called a dependent event. So again, I have, I'm going to put my slots out and you always multiply in between the slots. So 2 letters followed by 3 numbers, and I cannot repeat anything. So the first letter, it tells me, has to be a Q. So I know that that letter is going to be a Q. There's only one option of letters that can go first. After that, I have to have another letter, and how many letters are there in the alphabet that are not Q because I can't repeat Q? So there are 25 letters left that are not Q letters. Okay, and then I have to have numbers, digits. So if you look at the digits 0 through 9, that is 10 numbers because it includes 0. And so if we're not allowed to repeat those numbers, then I do have 10 choices of numbers here, but whatever that number is, I cannot use again. So now there's only 9 numbers left, and then there's 8 after that. So again, we just multiply those straight across, and that's how you deal with this non-repetition clause. When you multiply all those together, you get 18,000 different plates. Okay. Similar type of problem, 2 letters followed by a 4-digit even number with repetition allowed. Okay, so I can do 2 letters. I'm allowed to repeat, and then after that has to be a 4-digit even number. Okay, so I'm allowed to repeat, and I have to have 2 letters, so there's 26 options for the first slot, and there's 26 options for the second slot, followed by a 4-digit even number with repetition allowed. So I'm allowed to have one of 10 different digits here. I can have any of those 10 digits next because I'm allowed to repeat, followed by 10, but then this one has to be even. So the even digits are 0, 2, 4, 6, and 8. So that means there are only 5 options for that last slot. So that's how you take care of that even number part. So this is going to give us 3,380,000 different plates. Okay, so another one, 3 letters followed by a 4-digit even number, no repetition. So okay. 3 letters, 1, 2, 3, followed by a 4-digit number. So 3 letters, no repetition. So starting with letters, 26, then 25, then 24, because I'm not allowed to repeat letters, and there are 26 letters in the alphabet. 4-digit even number, no repetition. So here's where this one gets a little bit tricky, is that I'm going to start down here because that one has to be an even number, and then whatever this number is, that one can't be repeated here or here or here. So I'm going to do the even number first, and remember there are 5 even digits to end this even number, so there's 5 choices for that. But then remember, whatever number is here cannot be here. So here there's only 9 choices now. So 9 and then 8 and then 7. So that one looks a little bit different, and the reason for that is just because it has to be an even number and you can't repeat digits. When you multiply all that stuff across, you get 39 million, so a ton of different license plate options here if you're not allowed to repeat, and you have 7 different things. 312,000 plates. Okay, let's talk about number 3. There's 10 sprinters in a track meet. How many ways can they earn first, second, and third? So one thing that I did put up here, hopefully you caught that, is how to tell like when are you supposed to do what principle. In this case, whenever you're ordering people, that's your slot method. So I'm going to use that down here as well. How many different ways can they earn first, second, and third place? So first place, second place, third place. This is another repeat question that you may have seen in geometry, but if there are 10 sprinters, that means all 10 of them have a chance of winning. But then after that first dude crosses the finish line, how many people are still running? Only 9. And then 8. And so that's how we get 720 ways to award first, second, and third place. By the way, if you're wondering what's the difference between slot method and counting principle, so the slot method is just when you make your slots and you count down, kind of like that track example that we just did, and that's because the second person who finishes the race depends on the first person, so they are dependent events. But it looks the same thing as like the counting principle. That's for independent events. It looks the same way, but the yogurt choice does not depend on the granola choice, so that's independent. And so that's the difference. These problems look similar, but they are 2 different principles because one of them represents independent events and one of them represents dependent events. So this one is dependent also. How many different ways can 8 students get into single file line? Because the second person in line depends on the first one. So the first person in line, this is just like ordering people, it's the same thing, is 8. And then the second person, there's only 7 choices for that second person in line, and then there's only 6 choices. And then 5, count all the way down, 3, 2, 1. Notice how I'm not putting my times symbols just because that's laziness. Doesn't matter. Okay, this gives us 40,320 ways to line up people. And one thing that maybe you should think about is, maybe you've seen this before, maybe not, but this is the same thing as this thing called 8 factorial. If you've ever seen that exclamation point in math before, it's called a factorial, and what it means is you multiply the number times every single number below it until you get down to 1, and it's abbreviated 8 exclamation point, and it means factorial. And so I'm actually going to write down the formula for factorial for you. N factorial equals n, whatever the number is, and then subtract 1 from it, and then subtract 2 from it, and keep going. So I'm going to put those 3 dots. And you end when you get to 3, and then 2, and then 1. You end when you get all the way down to 1. So whatever your number is that you start with, you just keep subtracting until you stop at 1. So this is what 8 factorial looks like. And so what we can do is we can simplify some of them. And so 5 factorial means 5 times 4 times 3 times 2 times 1, which equals 120. Yes, there's a factorial button in your graphing calculators, and that will be very useful. I'll show you where to find that in class tomorrow. If you have a math option, it's in the probability area. You can be able to find it probably. Did you know that 1 factorial is equal to 1 because it just represents 1, and that's it? Okay, 0 factorial, here's something you're going to want to just memorize. You're probably going to think it's 0, but it's actually 1. That's something to memorize. There's a whole mathematical explanation for that I won't go into right now, but just keep that in mind. 10 factorial over 8 factorial. So this means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 8, 7, 6, 5, 4, 3, 2, 1. Mrs. Johnson, do we have to write this out every single time? No. What I want you to recognize is, if you remember properties of algebra 2, when you're multiplying stuff, all of that cancels and you end up with 90 on the top. And so one way that it might be more simple for you to write this is to go, okay, I know a bunch of stuff is going to cancel, so I'm just going to write 10 times 9 times 8 factorial, because I know that 8 factorial is all of these numbers. And then what I'm going to do is divide it by, the divisor here is just 8 factorial. That's a little bit simpler to still get the same answer. Okay, so just keep that in mind, that I'm going to use that kind of shortcut trick. I'm going to expect that you understand what's canceling here. How about this one? 7 factorial, let's try that shortcut. I'm going to do 7 times 6 times 5 factorial and 3 factorial, 5 factorial in the bottom. Okay, the reason why I wrote this 7 factorial as this is so that I could cancel my 5 factorials. That's a shortcut and a step that I want you guys to be able to recognize. 7 times 6 is 42. 3 factorial is 3 times 2 times 1, which is just 6. 42 divided by 6 is 7. And I am going to save those last two examples to do in class. They're a little bit harder. It's a warm-up. I want to be able to check in with you guys. So we'll take care of that in class tomorrow. Have a great rest of your night. Thanks for watching. See you tomorrow.